going to look at the histogram. So histogram, we are plotting the frequency against the upper class boundaries. However, we can use the histogram to obtain the median, but this is rarely asked. Usually we are using it to obtain the mode. Now the plot changes for equal and unequal class intervals. What do I mean? If you've watched the previous videos, you know that maybe if you're given something like max, you can have a column for the maybe here frequency. Then now usually we say you add a column for the class interval. So if you have a class interval of 10, 10, 10, this is okay. Plot frequency against upper class boundaries. And your plot will look something like this. Sorry, this is not what I'm trying to say. That the gap here is usually the same. I can't show this here because the gap is the same because the class interval is the same. However, when you have unequal class intervals, you're going to plot something called frequency density against the upper class boundaries, and you'll have something like this. Remember, these things don't have the same classes, so what I'm trying to say is that distance is not equal here because the class intervals are not the same. Now, how do we get frequency density? Frequency density is going to be frequency out of the class interval. Now, so we shall have something like max. We have frequency. Now here, their class, you're going to be getting something like 10, 5, 15, 10. So usually you're going to have something like this. So you have to add a column for frequency density. You see, you have to add a column for frequency density, where you say this frequency divided by the class interval, frequency divided by the class interval, and that's what you plot on this axis, on the y-axis here. Now, how do we find the mode? We're going to see that in a bit. So I hope this makes sense. So before you do any number, before you plot any histogram, ask yourself: are the class intervals the same? Are they not the same? And this skill usually comes with practice. If you don't practice, usually you're going to miss fire in the paper because you will answer the question and before you even know it, you will draw your normal frequency versus upper class boundaries. Then discover maybe after the paper that the class intervals were not the same and you had to plot frequency density. So that's what makes it very key and very important. Now we can use the histogram to find the mode, and that is the most commonly asked. So this is frequency and this is upper class boundaries. Never forget the title and the scale. Title and the scale, and also note we don't skip lines in while drawing the histogram. So how do we find the mode? You get your ruler, join these 2 points, look for the highest bar. See, this is the highest bar. Then extrapolate. This is the mode, whatever value you read of. Here we come, the same thing. Look for the highest bar. This is this. Join this to that. And another thing, don't shade the histogram. Some people say you should shade, but I don't think you should not shade it. You can leave it the way it is. So you see, we join. This is the mode. Some numbers are tricky. In this case, that you have something like this. You have 2 high, like the 2 highest points. So you do this and you do this. You get it. That's your mode. So here you have 2. Get both. Get here. Get here. Get the value. Get here. Get here. Get the value. So you can state both of them. You can say it has both, or you can sample. But after state both of them, then maybe you could find the average. But most commonly, you can just state both of them. Hope that makes sense too. Now, finding the median. As I've said, this is rarely asked, but we just still have to get the concept. So here you have, I want to put here something like 10, 15, 20, that it has to be 25, 30, and let's say this is 2, this is 4, this is 6. Here, let me put here, this is 3. Well, I want these points to be at known values because we're going to see why. Now, when you want to find the median, we're going to label this as you're going to get the area of all these shapes. So this is A1, this is A2, this is A3, this is A4. Now you're going to, here when you look at the dimensions, this is 2 and this is 5. 15 minus 10, this is 5. When you come to this longer one, this is 4 and this is 5 still. When you come to this one, this is 5 and this longer one is 6. When you come here, this is 3 and this one is 5 still. So you come and say what is A1. A1 will be 2 times 5 length times width, that is 2 times 5, that is 10. Hope this makes sense. What is A2? A2 would be 4, 4 times 5, that is 20. A3 is going to be 6 times 5, that's 30. Though I've told you it's very rarely asked for you to find the median using a histogram. Then F4, what is area 4 going to be? 3 times 5, that is 15. Now after that point, after getting the areas, you sum all of them. So we shall say 10 plus 20 plus 30 plus 15. We get 75. It's the sum of the areas. Now, the sum you get, you divide it by 2. So we say 75 divided by 2. What do we get? We get 37.5. Now, this 37.5, we are now supposed to get where does 37.5 lie in these areas. So now we know that A1 is taking up 10, like its area is 10. A2 is taking up 20. A3 is taking up 30. A4 is taking up 15. How we got the total of 75 was we were adding each of these. Now when we divide 75 by 2, we get 37.5. We want to get in this thing, where does 37.5 lie? Now 10 plus 20, we get 30. So to get 37.5, we have to get 7.5 from this, because this is from here to here is 30. Remember, we have 37.5, meaning to get 37.5, I just need a small portion from here to get 37.5. I don't know if that's making sense. Now that's where we are. That's the question. Now that's what we want to solve. So we realize that we have a value, a certain value of x here we need. Like that, so we need to get the. So okay, let's now pull out this box here. So it's this. Here we have 15. No, we have 20. Then we have 25. Then this is constant, it's 6. Now, I've told you we just want a small portion of this box, of which we don't know, like we don't know the length from here to that point one, so we are calling it x. And now, this thing that we want, its area should be 7.5. I don't know if you're making if it's making sense. So now I come and say 6 times x should be equal to 7.5. Then I come and say x of v 7.5 divided by x, divided by 6, sorry. 7.5 divided by 6. I get x is 1.25. Now this 1.25 is not the median, it's the value I have to add to this 20. So now I have to come and say here, when I add 1.5, in simple sense what we're trying to do, when I add 1.5 here, this is 1.5. This is the area covered by 37.5. It's somehow confusing, but you just have to know about it so that when the question comes, you're not at least blank. So you realize we are at 20 plus 1.5, 21.5 is the median. So I don't know if that makes sense, but that's how we find the median. If you have any questions, you can ask. So that's how we find the median from the histogram, but it's very rarely asked. Now, since we have our example here, now our example has equal class intervals. So I'm going to pause this and draw the table where we have max, frequency, and I'm going to add a column for class boundaries. Could also add for class, but we already know that the class is the same. So now we're here. We're going to plot the histogram. Here we are plotting the upper class boundaries. Here we are plotting the frequency. Why? Because the class intervals are the same. If the class intervals are not the same, we would have to add a column for frequency density. First thing always, write your title. A histogram showing, no one actually will read so much to see, but as long as you have the title there. So a histogram showing the marks obtained, or a histogram for the marks obtained by students, what? Then now the scale, we are going to get it now. So we do the calibrations. Here we have 1, 2, 3, 4, 5, 6. And then we have, what do we have on the frequency? Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. Now we are going to start with the frequency, and I think here also the frequency starts from 0. So with the frequency, start the frequencies. We have what's the highest? The highest is 24, but the lowest value you have is 0. So minus 0. Divide by how many? We have 12. So this is giving us 2, and that's exact. So we can just use 2. So this is 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Hope this now we've generated the scale. This is very close. So frequency. So you can even come here now, add scale, put vertical. 1 centimeter represents, write it in full, represents 2, maybe candidates, because this is number of candidates. Then now we come here. Now I told you it's very easy when the class intervals are equal. You can just come and see this is 49.5 plus 10, 59.5 plus 10, 69.5 plus 10, 79.5. The gap here should be the same when you try to subtract. It should be the same. That's where you have an equal scale. Otherwise, if it's not like that, you're going to lose marks. Your graph is going to be off. Then here you add 10. I think what would this be? 109.5, I think. So now come and start plotting. For this first one, it's 8. So it's 8. See? Usually you should also add your own. You don't rely on the add your own. Then you go to the next one. Though you should do this using a straight rule, just limit it. Then you go to 10. Then we go to 24. So something like this. 24. Then we have 8. So this. So you see. So we have this. So if you want to find the mode, maybe you'll be asked to find the mode. Don't forget to also add both scales. Horizontal scale, 1 centimeter represents. I think this is 10. Represents 10% because it's max 10%. You do this. Do this. Do this. Find your mode. Now, depending on the scale you've used, you should actually be keen, because here now, this minus this gives you 10, meaning here this whole space is 10. However, usually there are very many, but they are small boxes, and they are also usually 10. So you get that 10, which you have by subtracting this, and then you say 10%. Okay, let's say 10 small squares maybe have 10%. How about one small square? One small square would be 10 times 10% out of 10. So this is 1. So you would get 1. So one small square represents 1%. So here you come, maybe here is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So you have 5 small squares, but each small square is representing a percentage. So you add 5. So you add 5 to 69.5, and that will be your mode. But don't forget here there are marks for a scale, a marks for a title, a marks for labeling you. The marks, you're supposed to make sure this arrow is there on your histogram. Yeah, and this is how we plot the histogram. If there were unequal class intervals, we would have plotted frequency density against upper class boundaries. And also told you that This upper class boundary is just to guide you that we are plotting upper class boundaries, but here it should be marks in percentage. So I hope this makes sense. So now let's look at yeah, so this marks the end of actually statistics. Now I'm just going to put a very bulky exercise, but the main rule is to help you practice. No, I'm not going to be doing the numbers. I'm just going to be displaying the question and then I display the answer. And where I need to explain, I'll explain a thing or two. But yeah, we've finished the topic of statistics. Thank you for coming this far.